Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the different equation in circular motion, that is omega 2 equal to omega 1 plus alpha t, theta equal to omega 1 t plus this, this and this. That is fourth equation I will derive in two methods, general method and in calculus method. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam and NEET exam confidently with a good rank. So these equations are mainly class 11th derivations. That is, in two methods I will prove the fourth equation. So first, in general method. Now first define what is omega alpha t for time. Now first define what is omega. So there is omega is angular velocity. So there is a special video on angular velocity. I defined angular velocity equal to rate of change of angular position here. That is, when a body rotates in a circular path, this, then from, suppose this is a reference, from this line, this measure, from this line we measure the angular position, the angle. Suppose body is at here first, now it rotates in t second, angle theta, that is, it makes an angle theta at center in t second. So this theta is called here angular position of the particle, angular position of particle. For convenience, we can define this is the angular displacement also, but this is generally angular position of particle. So theta by t is defined as angular velocity. So theta by t equal to this, that is theta equal to omega t. Now omega 1 is initial velocity, omega 1 equal to initial angular velocity, omega 2 equal to final angular velocity, that is after t second angular velocity after t second, and rate of change angular velocity is angulation. What is alpha? Alpha is angular acceleration, which is rate of change of angular velocity, that is per unit second. What is the change of angular velocity? It is called angular acceleration. And theta is angular position, so its unit is radian per second, omega unit is radian per second. Omega actually is a vector quantity. Video have been made on angular velocities, so you can watch this video. Now today I will derive just the fourth equation. First, in general method, so first equation, omega t equal to omega 1 plus alpha, very easy. So from angular acceleration, alpha equal to angular acceleration, which is equal to rate of change of angular velocity, that is this alpha into t. So omega 2 equal to omega 1 plus alpha into t. Simple. From angular acceleration, this formula can be proved. Now second equation, theta. Second equation, to prove the second equation, what is, so in linear motion, in translation motion, what is distance travel? Distance travel equal to velocity into time. This is if the body moves with constant velocity, that is, then if the body moves with constant velocity, then distance travel equal to velocity into time. Now if the body has variable velocity, that is, if the velocity of the body changes, then we take the average velocity. So distance equal to, we take average velocity into time also. Now for angular displacement, for angular motion, this s is denoted by theta, that is theta and s are similar angular similar terms. S is linear distance or displacement, theta is angular position or angular displacement. V is denoted by omega and t. So theta equal to omega. Now here for proof of second equation, the body moves with angular acceleration. So that is body has, that is velocity changes, angular velocity changes. So we can define theta equal to omega average into t, like this, like the linear motion, distance equal to average velocity into time. So in angular motion, s is denoted by s is the similar term, theta is the similar as s. Now omega average equal to omega 1 plus omega 2 by 2 into t. Okay, omega average, so two velocity we take two values, initial and final, divided by 2. Now omega 1 plus omega 2 equal to, we know omega 1 plus alpha into t, which is equal to 2 omega 1 plus alpha into t, which is equal to omega 1 t plus half alpha t square. So this is the proof of second derivation. Theta equal to angular position. Now initially, suppose in this situation, suppose a body has here start, the body starts from this position, that is when t equal to 0, the body has, this is the reference line. From this line we measure the angle, from this line we measure the angle. So the particle starts from here. If the particle starts from here, and initial this position is theta 0. Now in t second, the particle rotates in this. Now suppose after t second, the particle reaches this position. Now this angle is theta. So what is the angular position? Now this angular position equal to, suppose this angle is theta 1. So theta equal to theta 0 plus theta 1. Now theta 0 plus theta 1. What is theta 1? Theta 1 equal to, if the particle starts with angular velocity omega 1, initial velocity, so theta 1 equal to omega 1 t plus half alpha t square. So here the equation will be this, that is, this is angular position, initial angular position, and after t second, what is the angular position? Theta equal to this. So if t equal to at t equal to 0, theta 0 equal to 0, then we can write this, that is, if the particle starts with reference line, that is from which the angle can be measured, the angle is measured, the line from which the angle is measured. If the particle starts from this line, then we can use this, and if initially it has an already angular position theta 0, then we can write this. So this is the equation. Here this equation, when, that is lines, when t equal to 0, theta equal to 0, when t equal to 0, the particle starts from angular velocity omega 1. So t equal to 0, theta equal to 0 from this. Now if t equal to 0, theta equal to theta 0, then we can write this equation. So this equation, this is the general method. In integration we define, in integration method, that is in calculus method, direct we get these equations, directly we get these equations. Now what is the third equation? From 1 alpha t, and from 2 so now we are going to prove this equation. So first equation is this, second equation we get this. Now from 1 we get t equal to this. Now if we put t at here, from 2 we get this plus half alpha, this. Now 2 alpha, this is alpha. So if this is the LCM 2 alpha, so 2 alpha theta equal to this, now cancel this, now cancel this and this, so we get omega 2 square, this and this minus omega 1 square equal to 2 alpha theta, so we get theta. So this is the third equation. Now we are going to prove fourth equation. Equation 4. What is this? Theta nth, like in linear, in kinematics, that is in linear motion, what is Sn equal to distance covered in last 1 second. If the body travels for n second, then the distance traveled in last 1 second is Sn. So Sn, like Sn, here we use theta nth. Theta nth means the angle produced or angle makes in last 1 second. If in last 1 second, if body or particles or body, if body rotates for n second, so the angle produced or makes in last 1 second if body rotates for n second, this is denoted by theta n. Now so this is actually theta n minus 1, that is if the body rotates, so if the body rotates for nth second, suppose this is nth second, from this is nth second, suppose this to this is nth second, this is nth second, this is theta n. Now this is n second, now this is theta n minus 1, that is this time is n and this time is n minus 1, so last 1 second angle covered is this, which is equal to theta n minus 1. So this, if we calculate this, then we get this. So what is theta n? Theta n equal to omega 1 n plus half alpha n square. If the body has an angular acceleration alpha, minus omega 1 n minus 1 plus half alpha n minus 1 whole square. So this equal to omega 1 plus alpha by 2 n square minus n minus 1 whole square, which is n equal to omega 1 plus alpha by 2 2n minus 1, that is last 1 second angle produced or angle makes equal to this, where alpha is angular acceleration. This is the general method. Now I am going to prove with calculus method. So next is calculus method. First, in calculus method, we know that is angular acceleration alpha equal to d omega by dt. In calculus method, angular acceleration equal to d omega by dt, we know that is d omega means very small change of omega in dt second. This is small change of omega in, this is change of omega in time dt. So d omega by dt is defined as angular acceleration. Now d omega equal to alpha into dt. Here alpha equal to constant, that is uniform, for uniform angular acceleration, alpha equal to constant. So d omega equal to alpha into dt. Now if we integrate this, now t equal to 0, angular velocity is omega 1, and after t second angular velocity is equal to omega 2. So integration of d omega is omega 1, omega 2, this is alpha constant, time dt integration is t. Now put the value omega 2 minus omega 1 equal to alpha into t. So omega 2 equal to omega 1 plus alpha into t. So this is the equation. So we get omega 2 equal to omega 1 plus alpha t. Second equation. Now omega 2 k we get omega. What is omega? Omega equal to d theta by dt. D theta by dt. This is the definition of omega. In calculus method, omega equal to d theta by dt. So omega 2 equal to d theta by dt. We define this. This equal to omega 1 plus alpha t. So d theta equal to omega 1 dt plus alpha t dt. If we integrate both sides, now when t equal to 0, d theta equal to 0, take d theta equal to 0. When after t second, final angular position is theta. So here d theta integration is theta 0 to theta omega 1. dt integration is what? dt integration is t, and alpha t dt integration is t square by 2. So theta minus 0 equal to omega 1 t plus half alpha t square. So theta equal to this. So when theta equal to 0, we take when t equal to 0, theta equal to 0. Now if t equal to, so this is the proof of second equation. Now if we put here theta 0 equal to 0, theta 0, then we get theta minus theta 0 equal to omega 1 t plus half alpha t square. Because t dt integration is t to the power 1 dt, this integration is t to the power 1 plus 1 by 1 plus 1. So this is t square by 2. So theta equal to theta 0 plus this. So this is the equation. Here initial angular position, this is called initial angular position. So in t second, what is the angular position of the particle? Theta equal to this. In after t second angular position, that is, this is the angular position after t second. Angular position after t second. Now third proof is this: omega 2 square equal to omega 1 square plus 2 alpha theta. In calculus method, we have to prove this. So we know angular acceleration alpha equal to d omega by dt. We know that. Now if we define as d omega by d theta into d theta by dt, we can write this way: d theta is adjusted here and here. Now d theta by dt equal to what? D theta by dt equal to omega d omega by dt. So we can write alpha equal to this. Now cross multiply this: omega d omega in one side and alpha dt is another side. So omega d omega equal to alpha into dt, integration of this. So in t second, in t equal to 0, omega equal to 0, and after t second omega. So suppose at t equal to 0, initial angular velocity omega 1, and after t second after t second final angular velocity is omega 2. Now what is the omega d omega integration of this is omega to the power 1, that is omega to the power 1 plus 1 by 1 plus 1. So this is omega square by 2 omega 1 to omega 2 equal to alpha into t. Now put the value of this: omega 2 square minus omega 1 square equal to alpha into t. So multiply this: omega 1 square plus 2 alpha Now if in question it is given that, when if it is given that when angular position is theta 0, then initial velocity is omega 1, that is the particle or body starts from angular position theta 0, not 0 angle, that is body starts with the body starts when his initial angular position is theta 0. Now when theta 0, then initial angular velocity omega 1, and after theta, when angular position theta, this is omega 2. So now here omega square by 2 equal to alpha into theta to theta. So this is omega 2 square minus omega 1 square by 2 equal to 2 alpha theta minus theta 0. So omega 2 square equal to omega 1 square plus 2 alpha theta minus theta 0. So omega 2, this is the equation. So this is the equation. Now fourth equation, time period and frequency. Time period and frequency. What is time period and frequency? Time period is denoted by t and frequency is denoted by n. What is time period? Time period is time taken to complete one rotation. Time taken to complete one rotation for a particle. So in what is that? The angle described by one time period is 2 pi, because this angle is t pi. So in t second, angular displacement is 2 pi by angular displacement or position. Angular position is 2 pi, and in 1 second angular position equal to 2 pi by t. So this is called omega equal to 2 pi by t, because in 1 second, what is the angle? In 1 second the angular displacement is called the angular velocity. So omega equal to 2 pi by t. This is the important formula. And what is the frequency? Frequency equal to numbers of complete rotation, in 1 second. So in t second, if the time period is t, in t second the body or particle described one rotation. In t second the body or particle rotates one complete rotation. So in t second, numbers of complete rotation equal to 1. So in 1 second, numbers of complete rotation equal to 1 by t, which is equal to n. So omega equal to 2 pi into 1 by t n. So this is important formula, and unit of omega is radian per second. Now so what is the problem? The problem is that if a body rotates in circular path with angular velocity suppose 2 pi radian per second square. This is the unit of angular circular path. So the problem is if a body rotates in a circular path with angular acceleration 2 pi radian per second square. So this is the unit of angular acceleration. Find the numbers of rotation. Find the numbers of rotation. That is n. That number of rotation in. Find the number of rotation in time 40 seconds. If body start with angular velocity pi by 2 radian per second. So this type of question comes. What is the problem? The problem is the initial angular velocity is given and angular acceleration is given. Now find the number of rotation in 40 seconds or 1 minute, etc. you are given. Suppose this is given in 1 minute. So what is the question? what so you have to first you have to calculate the total angular displacement. Total angular displacement you have to first calculate. Then what is the angular displacement? Theta equal to omega 1 t plus half alpha t square. So this is theta. Theta equal to what is this? Now what is omega 1? Omega 1 is pi by 2 into t is 1 minute, that is 60 seconds, plus half alpha equal to 2 pi into t square, that is 3600. Now 2 cancel, that is 30 pi plus 3600 pi, that is 3630 pi. Okay, so 3630 pi. So this is the total angular displacement. Now numbers of rotation, we know in one rotation angular produce is 2 pi. So number of rotations will be 3630 pi divided by 2 pi, that is at times number of rotation is this. So simple, you can use this type of equation for solving problem. So I will discuss the important problem of circular motion in another video. Now this is the end of the class today. Okay, thank you.